Okay, welcome to the second installment of the Flipped Classroom. Today we're going to talk about our physics unit, or the beginning of our physics unit, which we begin with speed, velocity, and acceleration. Our objective today, we're going to be covering TEK 8.6b. You will need to be able to, at the end of this video, differentiate between speed, velocity, and acceleration. So we will contrast speed, velocity, and acceleration by solving word problems and investigating the motion of objects while calculating speed, velocity, and acceleration. Your notes this week are due Monday. Starting Monday, we'll have stations, and at those stations, you'll practice calculating. And then for the rest of the week, we'll have labs that you're looking at the speed of objects, and you'll be calculating speed, velocity, and also looking at acceleration. Let's talk about motion. When an object changes its position, motion has occurred. So the distance is how far the object moved. Displacement is how far an object has moved in relation to its starting point. You always have to consider direction whenever you're thinking about displacement. So our example here, two runners travel along the same straight path in a straight line for 500 meters. At the end of the run, their distances are the same, but their displacements are different. How can this be so? So what I'd like for you guys to do before Monday is look at examples of displacement. You can go to our library resources and type in displacement and come up with a good solid definition, and then be ready on Monday to explain how two runners can travel in a same straight path in a straight line for 500 meters and have different displacements. Okay, speed and distance. The relationship between speed, distance, and time is represented as a formula. The formula for speed is distance divided by time, and we'll often denote it by having distance / time. Remember, whatever's on top of this or to the left of the slash is what is being divided. Whatever is on the bottom is divided into the top. So distance is divided by time. You have a couple of different types of speed. Constant speed means that the speed does not change over time. So you're always traveling at 5 miles per hour. Never slowing up, never speeding up, never slowing down. Average speed is the speed of motion when speed is changing. So your average speed is always your total distance divided by the total amount of time that it took you. Instantaneous speed is the speed at any given moment in time. This would be if you're driving in a vehicle and you look at the speedometer and the speedometer says 35 miles per hour, that's the speed at that moment. In 5 minutes, the speed limit may have changed and the speed may increase or decrease accordingly. When we're talking about motion, there's always, and speed and velocity and acceleration, all of it, you're always going to have some kind of graph involved. It's normally going to be a line graph because you're going to be looking at a change of distance over a course of time. And you always graph the distance on the y-axis and the time on the x-axis. Speed is equivalent to the slope of a line because distance is always on y and time is always on x. You can find the speed by calculating the slope of the line, which is rise over run, or distance over time. We will have a constant speed lab where you guys have to calculate slope next week. So if you have not calculated slope before, you'll want to visit with me during tutoring. Okay, there's a few different ways you can see distance and speed on a graph. If you have a straight horizontal line, that means something's not moving. You can see the distance isn't changing, but the time is still going. So let's say a runner stops to tie his shoe. That point in which the runner has stopped running, but the time is still elapsing during a race, would be indicated with this straight horizontal line. It means time is still going, but no distance is being changed. If something starts out slow and then speeds up, its change in speed can look like this. You have a very gradual incline like this, and then you have a steep slope along here. And this would be the point at which you had a change, the first initial change. And then you'll gain distance as the time elapses. This graph shows several stages of motion. We know that something's moving because distance is changing. You have stage 1 in this dark blue. Okay, they went 100 meters in 10 seconds. At stage 2, they covered 50 meters in 10 seconds. And then at stage 3, they covered 150 meters in 20 seconds. What I'd like for you to do is, using the speed formula, distance divided by time, you're going to calculate the speed as indicated by each of the colors. So you'll have a speed for stage 1, stage 2, and stage 3. And then you're going to calculate the average speed and tell me what the total distance is. So go ahead and pause the video now, and in your notes do these calculations. Okay, we're back, and we're going to go ahead and look at the calculations that you just completed as part of the video. Okay, in stage 1, we covered 100 meters in 10 seconds, and so we took 100 meters, that's our distance, divided by 10 seconds, that's our time, and our speed, in stage 1 was 10 meters per second. In stage 2, we used the same formula, speed equals distance divided by time, 50 meters divided by 10 seconds, and you came up with 5 meters per second. In stage 3, you had 150 meters covered in 20 seconds, so you ended up with 7.5 meters per second. For your average speed, you had to take your total distance divided by your total time. So we had a total distance of 300 meters and a total time of 40 seconds. And so we came up with 7.5 meters per second, and the total distance covered was 300 meters. Let's talk about velocity. You have to be able to differentiate between speed and velocity, and it's pretty simple actually. Speed is going 50 miles per hour or 100 kilometers per hour. Velocity is the speed and a given direction of the object's motion. So if you said that you were going 88 kilometers per hour southwest, that's velocity. If you said you were going 88 kilometers per hour, that is speed. The formula for velocity is the same as speed, distance divided by time. But with velocity, you must tell us what direction the object is traveling in. Acceleration. Acceleration is a change to speed or velocity. Acceleration is any change. You can increase speed, you can decrease speed, you can stop, you can go, you can change direction. You can go left or right, north, south, east, west. You change those directions, it's acceleration. The formula is your final velocity minus your initial velocity divided by a change in time, and it's normally measured in meters per second squared. So here's your practice problem. A roller coaster has a velocity of 10 meters per second at the top of the hill. 2 seconds later, it reaches the bottom of the hill with a velocity of 20 meters per second. What is the acceleration of the roller coaster? Go ahead and pause the video, set up your equation for acceleration, and solve it. Okay, so we had our practice problem. You guys took the time to solve it. Our final velocity was 20 meters per second. Our initial velocity was 10 meters per second, and the total change in time is 2 seconds. So you set up your formula, 20 minus 10 over 2. So 10 meters per second divided by 2 seconds, and your answer is 5 meters per second squared. And that's really all there is to speed, velocity, and acceleration. And be ready with questions and all your notes on Monday. Have a great weekend.